Hello. In this video, I'm going to talk about relative maximum and minimum point. Okay, relative maximum and minimum point, or we can just say it as relative extremum point. Okay, relative extremum. So relative extremum. So to describe the maximum and minimum point. All right. So actually, there is also another name which is called as local maximum and local minimum. Alright, they will use another term which is local and local maximum and local minimum point. Alright, so I'm going to tell you what it means by relative maximum or local maximum point here. So first, before I tell you what is it, so I have to teach you how to identify the local maximum and minimum point from a function, from a curve, right? From a curve. Okay, this is a polynomial, right? Polynomial. Every polynomial, okay, do you know that every fx have a critical point, all right? Have critical point. So in the previous lesson, we learned about critical point. The critical point is consists of a point where the point is a stationary point, dy dx is 0. The first derivative is 0, or the first derivative is undefined. But for polynomial, okay, I have to tell you, for every polynomial, there are no dy dx that are undefined. The dy dx is always defined. It's always defined, and dy dx, we just need to consider the stationary point. Means that the critical point for polynomial, critical points for polynomial is always give you stationary point, right? Will always give you stationary point. Means that you just need to consider dy dx equals to 0, or we said f prime x equals to 0. So we consider the f prime x or dy dx equals to 0. So the stationary point. So after we identify the stationary point, we need to identify whether the nature of the point, either they are maximum or minimum point. All right. So let's see what is actually I talking about. So, for example, these cases here is a cubic, right? It's a cubic function. So of course, before that, I don't know how to sketching this cubic function except if I have an apps. All right. So by knowledge of mathematics, without apps, we actually can finding the turning point, which is the stationary point. So we differentiate, we're getting 3x to the power of 2 minus with 12, right? 3x power of 2 minus with 12, right? So then we want to find the stationary point, okay? The relative maximum relative point. So we take f prime x equals to 0. There are no f prime x undefined. There are no, because it's always defined for this function, right? It's always defined, means x can accept any value. So 3x power of 2 minus 12 equals to 0, right? Then we divide by 3, then we have 4, 3, 12. Then we are getting x minus 2, x plus 2 equals to 0. Then we are getting 2 point, all right? We were getting 2 stationary point, which is 2 and negative 2. So at first we can find negative 2, okay, the y value, the coordinate for negative 2, right? So when x is negative 2, we can find the value of y. Always substitute this into the equation here. Actually, y here is represent the y value. So which is negative 2 to the power of 3 minus with 12, negative 2, negative 5. All right, same thing for this. The y value will be 2 to the power of 3, 2 to the power of 3, minus with 12 times 2, minus with 5. Then we will get the value of y. Alright, after using calculator, we calculate, we were getting 11 for this case. We're getting 11. So as you substitute the 2 into the function here to find the value of y, so you calculate 2, you will have negative 21, right? Negative 21. So which give you 2 coordinates of stationary point, okay? Which will be negative 2, 11, negative 2, 11, and negative 21, 2, negative 21. All right? Okay. For now, we don't know we're not sure whether these two, which is a relative maximum and relative minimum. So then later I'm going to introduce you a test, a first derivative test. Okay, we talk about first derivative test. I'm going to talk about two types of tests in the same video. In this video, I'm going to talk about two types of tests. One is the first derivative test, and later I will talk about second derivative test. So now let's focus on first derivative test. So first derivative test refer to first derivative. First derivative means the dy dx, the sign of dy dx. Okay, the sign of dy dx was very important. So let's see. I have -2 and 2, right? -2 and 2. So I'm going to divide my table to like a number line, right? Like a number line. So we have -2, -2, and 2, right? I have -2 and 2 as my stationary point. -2 and 2. So then we want to know that what happened during this interval, right? I'm going to build the table. Okay, this table, of course, this is your interval. Okay, interval of x, and this is your sign of the f prime x, positive or negative. That's the meaning, sign. So and the nature, okay, or we said the shape of the graph, shape of tangent. Okay, shape of tangent. So now we just need three row, so you can make a conclusion later. -2 and 2, right? You know that during this time your gradient is 0. There are no sign. dy dx is 0. During 2, when x equals to 2, dy dx is 0, right? So we just want to identify what happened, right? Before and after. So very easy. So -2. Before -2, I can negative infinity up to -2, right? This is -2 up to 2. Any number in between this, between -2 and 2, and this is 2 up to infinity, right? So we're going to break it into 3 regions. For these 2 points, then we have 3 regions. So then we are using our calculator to identify the sign of f prime x when x less than -2. All right. So we want to identify the sign of f prime x during less than -2, right? So we can choose any number less than -2, -3, for example, less than -2, -3. So I'm going to substitute it into the f prime x here. So in calculator I key in 3 alphabet x squared, right? Minus with 12. Okay, the gradient function, the f prime x here, 3x squared minus 12. So now I calculate. So choose a number that less than -2. All right, less than -2, before -2. So I can pick -3. Okay, -3. So I equal, double equal. Then I get a positive value. Don't care what is the value here. It is a positive value. So I'm putting a positive here. A positive number here. So then we look at between -2 and 2, right? Between -2 and 2, all right? Between -2 and 2. So we choose a number. You can choose 0, 1, or -1. Okay? You calculate -1 equal. You're getting a negative number. So if you calculate 0, you are still getting a negative number. Okay? Because in between this, you can choose -1, you can choose 0, right? Calculate 0, -12, right? So calculate 1. 1 is still in between these two, so you are still getting negative number. So means that the gradient here is the sign of the f prime x is negative. So how about after 2, right? After 2, so we calculate for a number after 2. After 2, 3, 4, 5, 6, anything. 2.1 also can, so we choose 3. So 3 equal, then we have positive, right? You calculate for 100 also, it's still positive, right? So then you have positive, negative, positive. So according to the concept of straight line, right? So if the gradient, the tangent for this one is positive, right? Positive. The sign for dy dx positive. If the gradient is this way, going to the negative, okay, slant, okay, means that decreasing, okay, decrease, turun tangga, naik tangga, okay, naik tangga, turun tangga. So this one is negative, right? Going up the stairs, going down the stairs, so negative. So now positive, going up, negative, going down, right? Negative, going down, positive, going up. So now by looking at this, we can know the nature of -2, right? We can know that -2, can you see that? The curve to be this way, means that it's like positive gradient, later dy dx 0, because during -2, the dy dx is 0, right? Means there is a stationary point here, dy dx 0, dy dx 0, and this is dy dx less than 0, dy dx less than 0, right? Less than 0, and dy dx here more than 0, right? Positive, the tangent here positive. So this can describe that this point is actually a maximum point. So means that -2, which is this, is a relative, we use the word relative maximum point, right? Relative maximum point. So how about 2, right? How about 2? So we look at the graph here, going down and going up. So means this one shows that going up, going down, going up. So there is a stationary point here, dy dx 0, which is 2, right? Which is 2. So during here, you see the gradient, so it's negative, dy dx less than 0. And after this, your dy dx will be greater than 0. So this one shows this is a local minimum point. Out of here, out of all the point here, this is the minimum one. So we said -2 and the 2, -21 is a relative minimum point, alright? Minimum point. So now we know that this is a maximum point and this is the minimum point, relative minimum point. Alright. So, okay. Then I'm going to show you how to using, this is your first derivative test, how to using this to sketching the graph of this function here. Right? Alright. Okay, let's see how to using this table in sketching the graph. Very simple. So you have the graph of cubic. So this is the most proper way of sketching a cubic curve here. So first we look at this case here. We have two relative maximum minimum point here, right? One is 2, -21, right? 2, -21, right? Roughly we just know is 2, -21 is here, right? 2, -21, and followed by -2, 11, right? -2, 11. So -2, 11, okay, somewhere around here. Now this is the 2 point, right? It's also a stationary point, or we said turning point in this case here. So now based on this is the -2 is a maximum point, relative maximum point. So the curve going to moving this way, right? Going to moving up, and then stationary here, stationary, berhenti sekejap, then there will be intersect the y-axis, intersect y means x is 0, right? X 0. So x 0, what is the value of y? Y. So x 0, x is 0, x 0, then you have y value to be -5, right? So means they will intersect at -5. So be careful. So they will intersect at -5, means they will intersect at -5, not up here, but -5. And going down, they're not going down because there is another turning point here, which is the relative minimum point, So they were going this way. So they were going down and then going up again. So this is the curve. This is the cubic, the graph for this cubic function here. So based on this first derivative test, you know this is a relative maximum, relative minimum. Okay, now I'm going to tell you what is the meaning of relative maximum, right? Relative maximum is the maximum compared to the neighboring point. You see the neighboring point, jiran, titik dekat jiran ini, okay, titik jiran. So and the neighboring point, so it's much lower than here, right? Much lower than this point. So that's why we said relative. Compare to others, this point is considered maximum. But actually the graph can go beyond, right? Go to infinity. This is not the absolute maximum. So it means that there is even bigger value of y here. But for this region, this is considered as maximum. So we put the word relative. Relative maximum. Okay? And this one we talk about, this is a relative minimum, because in this small region here, the neighboring point here, this is considered the lowest point compared to other point. Alright, compared to others point. But if you compare this graph will going down, further down until negative infinity, and this is not the lowest point. There is another lowest point, right? So that's why we said relative minimum. But for quadratic is only one minimum point, right? One minimum point. So there are no other minimum point. So we know we never use relative. We never use relative minimum point for quadratic. When you learn quadratic, your teacher never said find the relative minimum point for quadratic, right? They never said that. Because why? Quadratic is only one minimum point, and this is the lowest point, right? Lowest point. So for example, find the maximum point. There is only one maximum point. The rest, the rest of the graph, all is lower compared to this point. So this is the highest point. This is the lowest point. So we never use the word relative for quadratic. But for cubic, we use the word relative. Why? Because yes, this is the highest point at this region, but not overall, because there are even highest point over the curve in other places here. So now I'm going to teach you how to using first derivative test. Okay, this is the first derivative test. Okay, how about second derivative test? All right, let's talk about second derivative test. Okay, second derivative test is very easy. As if the second order, second derivative, right? Second derivative means d2y dx2. Okay, dx2, d2y dx2. So if this is a negative number, less than 0, negative. Okay, if you get the test to be a negative number, if the test is a negative number, then this one tell you that the point is a maximum point, right? Relative maximum point. So it's a relative maximum. Alright? So if the d2y dx2 is greater than 0, then we said positive. Positive. Then we said that point is a relative minimum point. Relative minimum point. So this is just another test to identify whether this is maximum or minimum, right? Beside first derivative test. So if let's say the test is equals to 0, means doesn't show not positive or negative, okay, not positive and negative, alright, then we said the test failed, right? The test failed. So if the test failed, it's better to go back to first derivative test. So it means first derivative test is more powerful. Okay, first derivative test is much more powerful compared to second derivative test. But second derivative test is easier. Okay, it's easier. So okay, your first derivative. Now you know that your first derivative is 3x squared minus 12. Right. So of course you need to find the second derivative, because second derivative test. So differentiate, you have 2, 3. 6x. Differentiate, you're getting 0. So this is the test. So this is the meaning here. So for when x is negative 2, when x is 2, what happened? Okay, very simple. When x is negative 2, when x is 2, when x is negative 2, so put the value into the second derivative. So you have negative 2, 6 times negative 2, you have negative 12, a negative number, right? A negative number. And you're putting 2, you're getting a positive number. You're getting 12, positive, greater than 0, right? So according to the test, if negative, then we said negative 2, 11 is a relative maximum point. Alright? It means that this is a relative maximum point. So for this one, you're getting a positive, the sign is positive, so it's a relative minimum point. So it means that this is a relative minimum point. Here, can you see that? A relative minimum point, relative maximum point. That's all, right? This is much more easier compared to first derivative, but it sometimes won't work when you get d2y dx2 equals to 0. That's the problem of second derivative test. So then you have to further inspection by using first derivative test. Alright, okay, in this video I talk very many things because I introduced you the first derivative test and second derivative test. So I'm going to do 3 more video about the relative maximum and minimum point. So see you in the next video.